Good morning, everyone. My name is Vera Suzette Pisakayan, and I am an AET student of ISAT. So, AET is a course that tackles instruments and electronics in an aircraft. For today, I'm going to discuss about autopilot, the basic operational principles of autopilot, autopilot engagement, and load threshold. So, our first topic is all about autopilot. What is autopilot? Autopilot is a system created to control an aircraft and lessen the pilot's workload. The autopilot has the ability to maintain altitude, climbing or descending to an assigned altitude, turning to and maintaining the assigned heading, intercepting a course, guiding an aircraft between waypoints, and flying or landing in a precision and non-precision approach. The precision approach uses ILS or Instrument Landing System or MLS or Microwave Landing System. In the non-precision approach, it uses VOR, RNAV, and DME. Though the autopilot is as helpful as I've described it, the autopilot cannot operate without the flight director. The flight director is the brain of the autopilot. It is designed with computational power and can provide information to the pilot even without the engagement of the autopilot, though the aircraft must be flown manually if so. The autopilot is pre-programmed through the MCDU. All needed information during flight is input in the MCDU to ensure that the system will work properly. If the autopilot is not pre-programmed, inaccuracy may occur. The autopilot has two functional modes, the lateral and the vertical. The lateral mode controls the ailerons, spoilers, rudders, and the nose wheel through different computers such as the ELAC, SEC, FAC, and VSCU, while the vertical mode controls the elevators and the trimmable horizontal stabilizers, one of which is basically chosen by the system or the pilot, and once the autopilot is being engaged, one mode of each is simultaneously active. Aside from this, the autopilot has two modes of operation, the manual and the automatic. In the manual mode, the pilot needs to continuously provide inputs such as the heading, the altitude, and the speed at which the aircraft needs to fly. These inputs are programmed through the FCU or the Flight Control Unit, which will in turn be sent to the autopilot and autothrust computers, which will control the aircraft accordingly. These changes in inputs are mainly instructions from the ATC during flight and for short term only. In the automatic mode, it is used for most of the flight time and is programmed through the MCDU or the Multi-Purpose Control and Display Unit. The flight plan is inserted in the MCDU to be used as a reference for the autopilot system. The flight plan contains information such as the heading, the altitude, and the speed at which the aircraft should fly. Now, all the pilot has to do now is to monitor the operation of the system and take proper action if any error occurs. On another note, if the autopilot is engaged, never try to help or assist it because interference in the operation may result to total loss of control. Only interfere if you are ready to manually fly the aircraft. Even if the autopilot system makes everything easier, the pilot must have an overall awareness of the situation to ensure that errors and failures will not occur. Most importantly, the autopilot system cannot replace the pilots because it is the pilot's job to fly an aircraft and ensure the safety of the passengers. Moving on to our next topic, which is the autopilot engagement. We're already done discussing a few general information about the autopilot system. Now the question is, where is it located? The autopilot push-button switches are located on the cockpit's glare shield, or specifically on the FCU or the Flight Control Unit. There are two autopilot push-button switches. The autopilot 1 is for the captain and the autopilot 2 is for the co-pilot or first officer. This is designated to ensure that transponder is using the correct ADIRS or Air Data Inertial Reference System to report the aircraft's altitude. If you're wondering as to why it is connected to the aircraft's altitude, It is because the designated button will use the altitude data to whichever is engaged. For example, if the autopilot 1 is engaged, then the transponder will use the captain's altitude data. Even though there are two autopilots, only one autopilot can be engaged at a time. However, in the case of ILS automatic approach, both autopilots may be turned on to ensure the best level of redundancy required to safely achieve auto lands, auto rollouts, and low altitude go arounds. So basically, the autopilot 2 exists to ensure the best level of redundancy. How do we engage the autopilot? The autopilot is engaged by pushing the designated button on the FCU. To monitor, an indication is displayed on the top right of the PFD or the primary flight display to confirm that the autopilot is indeed engaged. The autopilot can be engaged while the aircraft is on the ground and both engines are shut down for maintenance purposes. If any of the engines are started, the autopilot disengages. During takeoff, the autopilot can be engaged provided that the aircraft has been airborne for at least 5 seconds or if the aircraft is above 100 feet or so. During cruising, only one autopilot can be engaged at a time. If the second autopilot is engaged, it will disengage the first one. During landing, as I have said earlier, both autopilots may be engaged to ensure the best level of redundancy. The autopilot will be disengaged if interference in the process occurs, such as takeover push button is pressed on either side stick, the corresponding autopilot push button on the FCU is pressed, the opposite autopilot is engaged, if one or more of the engagement system is lost, and many more. In this part, we will understand the autoflight basic operational principles. It comprises of database loading, power-up test FD engagement, the MCDU utilization, auto-thrust engagement, and autopilot engagement. Database loading is an essential but time-consuming chore in today's intensive software aircraft. The aircraft software is updated to ensure operational efficiency, but only the navigation database is periodically updated. Next is the power-up test FD engagement. An electrical power-up test is done before the flight director is engaged. As soon as the electrical power-up test is done and electrical power is available, the flight director automatically engages. MCDU initialization is when the MCDU is prepared for flight. This includes inserting important information such as the flight plan, the choice of database, RNAV inputs and checks, and inserting performance data. The information programmed in the MCDU is taken into account by the flight management and confirmed by the illuminated lights associated with the system on the FCU. Autopilot engagement. As I have said earlier, the autopilot is engaged on the FCU. Once the autopilot is engaged, the autopilot push button will illuminate and an indication on the top right of the PFD will be displayed. Only one autopilot can be engaged at a time. However, in the case of ILS automatic approach, both autopilots may be engaged to achieve the best level of redundancy. And for our last topic, the load thresholds. This applies to the side stick and the rudder pedals. A threshold is defined as a magnitude or intensity that must be exceeded for a certain reaction, phenomenon, result, or condition to occur or be manifested. It is somewhat a limit to the flight controls I've stated. But in aviation, exceeding the load threshold will result in the autopilot disconnection. Warnings are provided when the autopilot is disconnected or disengaged. When the autopilot is disengaged manually by pushing the takeover push button on the side stick, temporary visual and audio warnings will alert the pilot. If the autopilot is disconnected or disengaged due to failure or a force on the side stick, continuous visual and audio warnings will alert the pilot until the instinctive autopilot push button will be pressed to cancel it. That's all for today. I hope I have discussed these topics properly and clearly. Thank you for listening. Again, this is Vera Suzette P. Sakayan, signing off.